Hello. Now we are going to look at transformations, how we can move shapes around in different ways. First of all, we're going to look at translation, which is just instructions on how to move each point in the same direction by the same distance. So in this case, we are going to translate our shape here, our L shape, by the translation D to E. So this half arrow here means vector, and it just means that we're going from D to E. So the same way that we would move from the point D to the point E, we're going to do that same move to all of the corners of our shape. In this case, I've drawn in D and E here. We could also be given them as coordinates, and we'll look at that in a moment, but we're going to do this visually first. So we could be asked to construct this, so we'd use our ruler and our mat set in order to be able to move the same distance by the same amount. Here we have a grid, so we can do the same thing. We can do the same thing by counting how we move the point D to the point E. It's worth noting briefly, it makes a difference which letter comes first. Going from D to E means moving up along that diagonal. If we'd been told to use the translation E to D, if the letters were the other way around, that would mean going down to the left. So we need to be careful which way around those letters are. But in this case, going from D to E means we go to the right 2 and up 1. So that's all we're going to do for all the corners of our shape for our translation. So we start at A and we go across 2 and up 1. So the image of A is just going to be moved along like that. We often use dashed lines. If we're using our ruler to try and mimic DE, we'd often put dashed lines in to guide the eye. B is going across 2 and up 1 the same way. So B's image ends up there. So we've gone across 2 and up 1. C's image is going to go across 2 and up 1. It's going to end up there, across 2, up 1. We put our dot there, and the image should look identical. Draw that in blue. This should look identical. It's just been shifted to a different place on our page, but it's exactly the same other than that. Now we actually use translations in non-pure geometry questions as well to move points around from time to time, for instance, using area formulas sometimes. So if we started at the point A and we wanted to use the translation from D to E, how do we go from the point D, which is at in the door 0 up the stairs 4, in the door 0 up the stairs 4, to the point E, that is in the door 2 up the stairs 5, in the door 2 up the stairs 5. Well, it's exactly what we already said. Do this in a different color. It's exactly what we already said on the diagram. We add 2 to the x. We went across 2, so x goes bigger by 2, y goes bigger by 1. 4 to 5, we'd add on 1. So if we wanted to go from A to A's image, we'd do exactly the same thing. We'd say A is at in the door 1 up the stairs 3, and we want to go to A's image. And where should A's image end up if we're translating from D to E? Well, we just do the same translation. We should add 2 to our x and add 1 to our y. So we would end up at 1 plus 2 is 3, 3 plus 1 is 4. And did we end up doing the visual way? Did we end up in the same place? In the door 3, up the stairs 4. So A's image ends up at 3, 4. So we can see how our written version of this and our visual version of this give us the same answer. And if we understand our coordinate system, it's really the same argument, just written slightly differently. Now, another way that we can do a transformation is to reflect something in a line. And often the line that we are expected to reflect in is one of the axes, either the x or the y axis. So this is called axial symmetry or mirror symmetry. So axial because we often end up using the axis as our mirror, and mirror symmetry because it looks like a reflection. So let's have a look at what the reflection of this looks like in the y-axis. So just like standing in a mirror and looking at how far things appear back in the mirror, the further back you are away from the mirror, the deeper into the mirror you appear. So the point A is 3 units back from our mirror line of the y-axis. So the point A is going to have an image that is 3 units back. That is 3 units back from the mirror line. So we go in 3 units to the mirror line and we go out 3 units to the mirror line in exactly the same direction. For B, we are again 3 units back. We go 3 units to the mirror line, 3 units out again. That's going to be B's image there. And C is only 2 units out from the mirror line, so it's going to go out 2 units into our mirror. And we can see that our shape has been reflected. It is flipped over just like images in a mirror. So the stuff that's further back looks like it's deeper within the mirror, just like a reflection. So any intuition we have for how our reflections work in a mirror helps us to understand axial symmetry, or often called mirror symmetry as well. We can also have reflection under central symmetry. So this is where instead of reflecting through an axis, we reflect through a point. And in this case, the point we are going to use is the point 0, -1. I'm going to put a big dot there to keep track of where we are. And if we were using a ruler for this, we would use our ruler and sit it from our center of symmetry to the point we want to translate. We'll start with A, and we'd measure that distance, and then we keep the ruler in place or along the same line, and we go the same distance out to our image. Now in this case we have a coordinate plane, so what we're going to do is say, how do we get from A to our center of symmetry? Well, we go down 4 spaces and we go back 2. So then we would go down 4 spaces and back 2. So A's image would end up there. B's image, you go down 2 and back 2. So you go down 2 and back 2 to B's image. You go the same distance in the same direction out past your point as you went to get to your point. So we go down 2 for C and across 3. So we go down 2 and across 3. We end up at C's image. And we can see that the whole thing has been flipped upside down and reflected. So it looks a little bit different. And that's our central symmetry. Again, we can draw in our lines for going the same distance in the same direction out, and I'm going to draw them for you now. So we have our dashed lines drawn in. And again, with our ruler, we'd measure how far we'd gone out to our green dot, and we continue the same distance in the same direction out to our image. Now we can also be asked to rotate objects. So if we have our L shape here, our ABC, and we want to rotate it anti-clockwise or counterclockwise by 90 degrees, well, the clock goes around this way, so we're going to go in the opposite direction. If we rotate by 90 degrees, it can be helpful to think about vertical and horizontal lines. So if I rotate this by 90 degrees, this vertical line would end up on its side. It would end up horizontal. That can give us an anchor for what this should look like. So what's going to happen is we have to end up the same distance away from our origin. So we're going to figure out how far away we are to get to B, and then we want to rotate around, keeping the distance the same. So rotate by 90 degrees, keeping the distance the same. So we have to go across 2 and up 1 to get to B. If we rotate that by 90 degrees, we'd have to go up 2 and across 1 there, so we'd end up at -1, 2. That would end up being the image of B. A, we have to go across 2 and up 3, so we would end up going up 2 and across 3 in that direction. Again, it can be helpful to keep track of what was vertical and what's now horizontal. So A's image and B's image now form a horizontal line. They were vertical. And now C goes from 3, 1, and we would go 3, 1 for the image of C. So we have our image there. Now, how would we translate this rectangle A, B, C, D by the translation of the vector D to B? So we want to go from D to B. So how do we get from D to B? We go across 2 and up 1. So every one of the points in this rectangle are going to go across 2 and up 1. Or using our ruler, we would figure out the distance and the direction, and we do that to all of our points. So D is going to get translated to where B is. So that's where D's image is going to be. A is going to go across 2 and up 1. That's A's image. B's image across 2 and up 1. C's image across 2 and up 1. And again, you can use your ruler to keep the distance and the direction the same for all of the movements that we do. So that's our image under that translation. And then sketch the image of ABCD under central symmetry in C. We're going to do the same thing as we did here. So how do we get from A to C? Well, we're going to go across 2 and down 1. So I would go across 2 and down 1 again. Or using my ruler, I'd measure that distance and continue with the ruler in the same direction out to A's image. For D, I just go across 2. So I would continue out across 2 again to D's image. And B to C, I go down 1. So up to B's image, I continue same distance, same direction out past C. And I would end up with B's image there. And C is its own image because it is the center of symmetry, so it ain't going to move. So that would be my image under central symmetry. Again, you can do this with your ruler. You just measure the distance from B to C and keep the ruler in the same direction and go out the same distance again past C to get to the image of B, and so on. So that is how we can do our different transformations, our translations, our reflections in central symmetry, and our rotations, where we have coordinates and where we don't. And that is what we need for now.